Welcome to happy2050.org. Our topic today is once again the energy crisis, and here is where we left things at last time. We established that the decline of oil production would start in less than a generation, and that burning all coal, oil, and natural gas would only take a short century. Since fossil fuel is the fabric of our modern life, most people would agree that the better option is to manage the decline. But what exactly does that mean, managing the decline? Well, I think it means having the answers to three fundamental questions. By how much do we need to reduce our consumption? How quickly do we need to attain the reduction targets? And what are the tools we will use to get there? So far in our discussions on energy, we have set aside all concerns about the global warming consequences of burning fossil fuels, but now is certainly a good time to refactor in this aspect. A decline in fossil fuel consumption leads to a decline in carbon emissions, so the question becomes, what is a good target for the reduction of carbon emissions? A good place to start is to understand that no chemical reaction removes carbon dioxide from the atmosphere, so to make it go away once emitted, it needs to be absorbed by the natural carbon sinks of the carbon cycle. Today their capacity is exceeded, which is why CO2 concentration in the atmosphere keeps increasing. To stabilize this concentration, we therefore need to reduce our emissions to the maximum capacity of the sinks. A first good approximation is that the oceans and terrestrial ecosystems absorb 3 billion tons of carbon per year. If you take 1990 as a baseline, global CO2 emissions coming from fossil fuels for that year were roughly 6 billion tons. That is why the IPCC, as soon as 1996, published that in order to stabilize the CO2 level in the atmosphere, human emissions had to be cut to half the 1990 emissions. It's interesting to put this number in perspective because we're talking here about a minimum reduction target, which ambition is solely to stop the increase of carbon dioxide concentration. The ultimate objective will need to be far below that. And yet, the commitment from the Kyoto Protocol is to cut by 5.2% the emissions of developed countries sometimes before 2012. So it's a useful first step, but it's a modest one. Stabilizing is one thing, but the level at which we stabilize is essential because it determines the temperature increase the Earth will eventually face. These graphs from the IPCC give an interesting order of magnitude. They read like this. Let's say we eventually manage to stabilize the atmospheric CO2 at 450 parts per million. The temperature increase in 2100 will be between 1.2 and 2.4 degrees relative to 1990. By 2100, we'll be on our way to stabilization, but the temperature will keep increasing to stabilize, much later on, between 1.6 and 4 degrees. So if we strive to restrict global warming to 2 degrees at equilibrium, let's say to avoid the melting of the Occidental ice cap in Antarctica and the sea rise that would come with it, then we need to remain below 450 parts per million. The next question then is, how quickly must we start curbing CO2 emissions to eventually stabilize at 450 ppm? Another graph of simulation from the IPCC comes in handy here. Each of the red curves is labeled by the value at which CO2 concentration in the atmosphere would stabilize if emissions followed that curve. If we wish to stabilize at 450, we need to reduce emissions as soon as 2010 and keep reducing them with a steep curve before 2100. The non-negotiable conclusion here is that the eventual concentration of carbon dioxide depends on how quickly we start reducing emissions. We are now left with one instrumental question, which is, How can we dramatically reduce emissions as soon as possible? There is no quick and easy fix. Unlike a problem of local pollutant, or even unlike the hole in the stratospheric ozone layer, banishing a few items from our daily lives won't do the trick, because fossil fuels are in everything we do. Beyond the obvious, airplanes, cars, heating and cooling, fossil fuels are in the food we eat, in the music we listen to, in the coffee we drink in the morning, in web browsing, in the books and newspapers we read. It pretty much says it all when you realize that all plugged electronic devices consume energy, even when they are turned off. My next step will be to survey the solutions in consideration today and see if we are indeed heading towards a happy year in 2050. Thank you, and join us next time at happy2050.org.